You're watching Wave's discovery. At first, the data appeared to be nothing more than another entry in the endless tide of telemetry. Rows upon rows of numbers, long strings of timestamps, and photon counts that usually blend into the background. Week after week, the James Webb Space Telescope delivers oceans of such information. Its noble mission: to capture the faintest whispers of light streaming from the oldest and most distant corners of the cosmos. But hidden among those billions of photons was one dataset that refused to dissolve into noise. It pointed toward an object labeled 3 Atlas, an interstellar traveler cutting through our solar system on a hyperbolic path, destined never to return. At first glance, this seemed routine. Another icy visitor, another rock from the deep dark, briefly wandering near our neighborhood before slipping back into eternity. Yet what began as a typical observation slowly transformed into a discovery powerful enough to shake how humanity views its place in the universe. On paper, 3 Atlas looked perfectly ordinary. A dark body, fast and cold, the sort of visitor astronomers usually welcome as a chance to study the raw material of other star systems. But then Webb's instruments picked up something astonishing. A flicker. Not the chaotic sparkle of tumbling ice crystals. Not the brief shimmer of a dust jet. But something stranger, a repeating, deliberate glow. It pulsed with a rhythm so steady it felt engineered. The light spectrum concentrated itself in the near-infrared bands, the very same frequencies human engineers prize when building efficient systems. And this light was no random scatter. It wasn't smeared across the object like sunlight bouncing off ice. Instead, it appeared in structured bands sweeping across the surface as the object rotated. Imagine the night side of a planet lit by sprawling city grids, bright clusters of illumination, appearing and disappearing as the globe turns. The research team checked their data, then checked again. Could it be an artifact of the instruments? A calibration error buried in Webb's detectors? Or perhaps a plume catching sunlight at just the right angle? But every natural explanation collapsed under the weight of scrutiny. The emission lines were clean. The glow was consistent. And most importantly, the signals were stable, too stable to be the product of chaos. Stability is a fingerprint of engineering. And slowly, the data began to look less like nature and more like design. That realization carried profound consequences. It meant those photons were not being produced by chemistry alone. They were being shaped, directed, and organized by technology. And where there is technology, there must also be intention. Either whoever built those lights wanted to be seen, or the lights were serving some function, habitat illumination, navigational markers, or perhaps something that lies completely beyond our imagination. The sheer scale stunned researchers. For signals to shine so clearly at Webb's distance, the emitting structures must either be vast beyond comprehension, or built with a level of efficiency that borders on the miraculous. This was no flicker from tiny circuits. It was illumination stretched across enormous darkness. As 3 Atlas rotated, bright regions swept into view with clockwork precision, as if someone had arranged an array across its surface. The wavelengths skewed toward the same emissions one might expect from a civilization optimizing its energy for endurance and longevity. In short, Webb had not simply captured a random cosmic glint. It had recorded something that resembled an engineered nightscape, glowing across the surface of a wandering interstellar traveler. The weight of this observation is difficult to exaggerate. For centuries, humanity has asked, "Are we alone?" Radio telescopes searched the skies. Astronomers debated faint signals and statistical anomalies. The answers remained probabilities and silence. But now, the question shifted. We weren't debating noise anymore. We were holding a dataset in which photons behaved like the handiwork of intelligence. That realization raised unsettling questions. Was 3 Atlas inhabited in a way we would recognize? Could it be a derelict craft, its system still glowing faintly after unimaginable years? Was it a deliberate beacon, designed to catch the eye of anyone watching the skies? Or perhaps an autonomous probe, its durable systems carrying light across millennia as it drifted between stars? Each possibility carried its own consequences. If it was a beacon, then detection was the purpose. If it was functional, then the technology was engineered for survival in the harshest voids. Either way, our definition of interstellar objects had just expanded. And if even one out of the handful of known interstellar visitors carries techno-signatures, then maybe, just maybe, we have been overlooking a hidden population all along. The social response mirrored the gravity of the discovery. News of Webb's detection filtered slowly at first, passing through layers of peer review and cautious press briefings. Scientists who work with sensitive instruments know the danger of premature claims. But once the findings were validated, the reaction spread quickly: astonishment, disbelief, and careful restraint. Governments faced an immediate strategy problem. Should humanity handle this with openness, global collaboration, and transparent science? Or should secrecy prevail, data locked away, decisions centralized, and defenses quietly prepared? For astronomers, the challenge was far more urgent. Hyperbolic visitors do not linger. 3 Atlas was already retreating back into interstellar night. Observatories around the globe scrambled to capture every photon, stretching their instruments across radio, thermal, and optical bands. Each measurement brought new detail. Each observation sharpened the mystery. Yet even the firmest data could not answer the deepest question: purpose. We can measure strengths. We can chart periodicities. We can match spectra to materials. But intention? That remains the hardest frontier. And so speculation fills the silence. Perhaps the lights were not a threat, but a gesture. Perhaps, in the great loneliness between stars, someone decided it was worth signaling. We were here. If Webb's instruments truly caught a handshake in photons, then the galaxy is not empty. It contains interlocutors, minds capable of shaping light into patterns that carry across the void. 3 Atlas will depart, but the raw data remains. Scientists will argue for decades. New missions may be proposed. New instruments may be built to hunt for techno-signatures among future wanderers. For now, we are left with a single luminous hint: a dark traveler. A patterned glow. And the undeniable fact that the universe just became a little less silent. If this story moved you, ask yourself, what do you think the lights were for? A beacon? A vast infrastructure? Or the echo of technologies we cannot yet begin to imagine? Subscribe to Waves. Discovery for updates as scientists publish, as instruments respond, and as humanity dares to look deeper. And always, keep looking up. Because sometimes, the universe decides to say hello.